Here's number 1. You have 18 sine x equals to 9 times square root of 2. So the first thing you want to do is you're trying to get rid of this 18 and get sine x by itself. So 18 right now is multiplying sine x. So to get rid of it, you do the opposite. So the opposite of multiplication is division. So divide by 18. If you divide one side, you have to do to the second side. So if you divide 18 by this side, you got to do it to this side as well. So here the 18 cancel out. You have sine x. So now you can simplify. So 9 divided by 18, that's 1/2. So really what you have left is square root of 2 divided by 2. So if you remember from the unit circle, we have a square root of 2 divided by 2. So let's check the unit circle real quick. So look at these unit circle. We're trying to find sine. Sine is this second, right? Remember, if you remember, it's cosine comma sine. So let's see, square root of 2 over 2. Sine, you get pi over 4. Now, if you look over here, 3 pi over 4 also have a positive square root of 2 divided by 2. So these are the two possible answers. You have x can be pi over 4 and x can be 3 pi over 4. All right, now looking at number 2, you have 2 plus secant x equals to 0. Some people might struggle with this secant x, but it's not that bad. So let's just take a look. You have 2 plus secant x equals to 0. So you have this formula sheet. If you remember secant x, so secant, right, theta is really just 1 divided by cosine theta. Right, so we'll just rewrite that. So if you remember, right, identity, secant theta is really just 1 over cosine theta. So we just substitute, right? Instead of saying 2 plus secant x, we know is 1 divided by cosine x equals to 0. So this now is easier to look at because we know what cosine is. So let's solve for cosine x. First, we want to remove this 2, right? We got to get rid of it. Move it to the other side. So just subtract 2 to both sides. These cancel. You get 1 divided by cosine x equals to 0 minus 2 is just negative 2. Okay. So we don't like the cosine x to be, in the denominator. So, I mean, most of you right here, you guys know what to do, but I'm just going to, do step by step just to help everyone out if you don't remember. So first thing you want to do is get rid of this cosine x, so it's 1 divided by cosine. So the best thing you can do here is multiply by cosine x to both sides. right? These will cancel. You get 1 equal -2 cosine x. Right? And then now, how do you get cosine x by itself? Well, it's multiplying this -2. So to get rid of this -2, the opposite of multiplication is division. Right? So these cancel out. You divide by -2 one side, got to do it to the other side. So now what you have is really just cosine x equals to -1/2. Right? Most of you can get this answer like already from here. So that extra step you didn't have to do. But so now you have cosine x equals to -1/2. Let's go to our unit circle. So where is it that cosine is -1/2? Well, let's see. Cosine here is +1/2. +1/2. If you look at quadrant 2, here's -1/2. And quadrant 3, -1/2. So it's 4 pi over 3 and 2 pi over 3. So our answer here, x equals to 2 pi over 3 and x equals to 4 pi over 3. All right, so here's number 3. We have 4 times the sine square x minus 3 equals to 0. So 4 sine square x minus 3 equals to 0. First thing we want to do here is add 3 to both sides. Right, these cancel out. You get 4 sine square x equals to a +3. Right, 4 times, so opposite of multiplication, division. Right, to cancel that out, you get sine square x equal to 3/4. Now we have to get rid of this square. Right, the opposite of square is square root. So square root both sides. The square cancel. You get sine x. Anytime you square root something, you take the plus and minus. Square root of 3 divided by 4. So simplify. I'm going to write it so it's easy for some. Right? This is basically the same. Square root of 3 divided by square root of 4. So you get plus or minus square root of 3. We leave square root of 4 is just 2. So now sine x is equal to a positive of square root of 3 over 2 or a negative square root of 3 over 2. So if we look at our unit circle here, let's find where sine is square root of 3 over 2. So we have pi over 3, 2 pi over 3, 4 pi over 3 is negative square root of 3 over 2 right there. And then also a 5 pi over 3. So that's our answers. So you get x, it can be 4 pi over 3, 5 pi over 3, you get pi over 3, and you can do 2 pi over 3. Right, all possible answers. All right, now we have number 4. We have square root of 2 plus the secant x equals to 0. You guys remember from our formula sheet, the identities, the secant of x is equal to 1 divided by the cosine of x. So let's substitute, and we get square root of 2 plus, instead of secant x, we substitute with 1 divided by cosine x equals to 0. Where do we get this? Right here, right? Reciprocal identities. So let's solve for cosine x. Well, first let's subtract both sides by square root of 2. So these cancel. You have 1 divided by cosine x equals to negative square root of 2. Okay. We don't like this being this way, right? So we multiply both sides to get it on top. Get the cosine x on top. These cancel. You get 1 equals to negative square root of 2 times cosine x. Now we can get cosine x by itself by dividing both sides by a negative square root of 2. Right, so these cancel. See, now we have cosine x by itself, and that's a negative 1 divided by square root of 2. So we don't like the square root of 2 being in the denominator, and that doesn't help us find, cosine x on the unit circle. So what we can do is we can multiply this, right, by square root of 2 divided by square root of 2. This is the same as multiplying by 1, because anything dividing by itself is 1, but this helps us manipulate and get rid of the square root in the denominator. So when we do that, we get negative square root of 2, and square root of 2 times square root of 2 cancel, it gets you 2. Alright, so this times this equals this. So now this looks similar, right? This looks similar. Now we can find this on the unit circle. So where in the unit circle is negative square root of 2 over 2? So here, cosine negative 2 over 2. We gotta hit 3 pi over 4. And also 5 pi over 4. So x equals 3 pi over 4 and 5 pi over 4. Here's number 5. We have 4 times cosecant x equals to negative 8. So if you go to your cheat sheet here, your identity page, you remember that cosecant is basically 1 divided by sine, right? So we'll make a note of that. So cosecant x is really equal to 1 divided by sine x. So let's start solving first. So to get cosecant x by itself, here it has a 4 multiplying it. So the opposite of multiplication is division. So you divide the 4 to both sides. Gotta keep the equation balanced. So here now the 4 it cancel. You now have cosecant x equals to -8 divided by 4, you get -2, right? So now here we have this cosecant x. We're going to substitute now, right? Substitute this cosecant x with 1 over sine x. Okay, and to solve, we now multiply both sides by sine x. This remove the sine x from the denominator. You get 1 equal to -2 times sine x. And now to get the sine x by itself, you have to remove this -2. So this is -2 times sine x. So opposite will be division. So divide both sides by -2. The -2 now, they're gone here. They cancel out. So what you have left is just sine x equal to -1/2. So now you can use your unit circle to find where sine is -1/2. So here's our unit circle. Where is sine -1/2? Let's see. Here's sine +1/2, right? -1/2 would be right here. So you have 7 pi over 6. And also -1/2 is here, 11 pi over 6. So your final answer would be x equal to 11 pi over 6, and x is equal to 7 pi over 6. Here we have 2 sine square x plus sine x equals to 0. So all this is, it looks scary, but it's just factoring. Right? So if you look at this, what can you take out, right? What can you factor out? Well, you can factor out a sine x. So when you factor out a sine x, inside you get 2 sine x plus 1 equal to 0, right? Because if we distribute this back, you can see that sine x times 2 sine x equals to 2 sine square x, and then sine x times 1 gives you sine x. So now once you factor it out, you can set it to 0, right? And then solve. So sine x equals 0 is done. Here, to solve this, we have to subtract 1 from both sides. The 1 cancel. You get 2 sine x equals to -1. And then to get the sine x by itself, we have to divide both sides by 2. So this cancel. You now have sine x equal to -1/2. So now, once again, go back to the unit circle, find where x is -1/2. And pretty much just like earlier, right? Sine -1/2 at 7 pi over 6, 11 pi over 6. So we have here x equal 7 pi over 6 and 11 pi over 6. Now sine 0, where sine is 0, is either 0 or 2 pi. All right, here we have number 7. It looks really bad, but it's not that bad at all. So we got 7 cosine x plus 12 equals to 6 cosine x plus 13. All this is if we just combine like terms, right? These are like terms here, and then these are like terms. So we want these terms on one side and these on the other side. So to do this, just subtract 6 cosine x to both sides. Here it cancel. You get 7 minus 6 is 1 cosine x, right? We still have the plus 12. Here's the positive 13. And then now just to get rid of this 12, subtract 12 to both sides. Alright, these cancel. You get cosine x. 13 minus 12 is 1. So now what is cosine x equal 1? Alright, so let's go to our unit circle. Cosine x is 1 is either 0 or 2 pi. So x has to be 0 or 2 pi. Here's number 8. We have 10 times cosine x equals to 5 divided by Alright, number 8. We have 10 times cosine x equals to 5 times the square root of 2. So 10 cosine x equals to 5 times square root of 2. Well, first thing first, divide both sides by 10, right? To get rid of the 10. So you now have cosine x equals to 5 times square root of 2 divided by 10. Well, what's 5 divided by 10? It's 1/2. 1/2. That's it. So really now you have the square root of 2 divided by 2. So where is cosine x? That's equal to square root of 2 divided by 2. Well, let's go to our unit circle. Square root of 2 divided by 2, pi over 4. That's a negative, so it doesn't count. 7 pi over 4. Right? Positive square root of 2 over 2. So x equals 2 pi over 4. 7 pi over 4. Number 9. You have 4 times 10x minus 5 equals to 5 times 10x minus 4. Well, let's combine like terms. These two are the same, and these are the same. So we should subtract 10x to both sides. 4 10x, right? 4 times 10x. Now you have negative 5 equals 2. 5 minus 4 is just 1. And then you still have minus 4. So now you have these two. So what do? Pretty much opposite of subtraction, addition. So negative 5 plus 4, you get negative 1 equals to 10x. So Now we have to find where tan of x equals to negative 1. So in your unit circle, it doesn't give you the tan, right? But we know what is tan. Tan x is sine x divided by cosine x. So my advice here is, if you guys can memorize this, it will save you so much time, because instead of like doing this equation every time you gotta find the sine divided by cosine, if you take a look at the unit circle, it's always gonna be square root of 3. 1 square root of 3 divided by 3. That's really all you have to remember, right? This is 10. This is 10 right here. And it just reflects, like it's a mirror. So think about this. If this axis is a mirror, it just mirror over here. Right? If this axis is a mirror, it just mirror. And same thing, if this axis is a mirror, it'll just reflect. And now all you gotta do is you just have to find is positive or negative. So think about it. This is sine divided by cosine. So here is gonna be positive because sine here and cosine here is positive, right? So cosine sine. Here's positive, here's positive. The here cosine is positive, but sine is negative. So anytime you take a positive divided by a negative, you're gonna get a negative. So in this quadrant, you have cosine and sine. Here, the cosine is negative, and the sine is negative. So negative divided by a negative is a positive. So these numbers will be positive. Here, cosine, the cosine here is positive, the sine here is negative. So positive divided by negative, these will be negative, right? So if you can remember just this and you reflect it, right, it's like a mirror. The axis is the mirror. It just reflects. And this is, right, 30, 45, 60. So let's find where tan is negative 1. Tan is negative 1 at the 45 degree, right? Is these 45 degrees. But it's negative. So it's here and here. Right? So you look at your unit circle, it's here. So 3 pi over 4 and 7 pi over 4. So you get x equals to 3 pi over 4, 7 pi over 4. So my advice is you if you can remember the first quadrant, right? The first quadrant, 45, 30, 60. It's always going to be this. If you can remember that, you can get the rest of the quadrant. It beats doing this. All right, number 10, we have 15 sine x plus 19 equals to 14 sine x plus 18. This one is easy too. You just simplify here. All right, remember guys, we want to combine like terms. These are like terms. These are similar. All right, so what we do, we take this and move it over here. So let's subtract 14 sine x to both sides. These will cancel. 15 minus 14, you get 1. And this is what's left over. Now we want to move this to the right side. So subtract 19 sine x. These cancel. This, negative 1. Alright. Where is sine x equals to negative 1? Let's go to our unit circle. Sine negative 1 right here. Right? This is cosine comma sine. 3 pi over 2. Alright, so number 11, it is a little hard depending on how you look at it. You can do this in multiple ways. You can complete the square. You can do the quadratic formula. I find it easier doing it this way by factoring. So if you take a look, 2 sine square x plus sine x plus 1 equals to 0. So this looks really complicated. So what I like to do is, so let sine x be like t, right? So it's just substituting. We're just substituting because it looks better this way. So you get 2t squared plus 3t plus 1 equals to 0. So this looks a little better, right? It looks cleaner. It's easier to see. So from this point, you can complete the square. You can do the quadratic formula. I find this is to rewrite. The best way for me to do it is to rewrite like this right here. So obviously we can't really factor this right now, but what we can do is we can rewrite this 3t where it's you get 2t squared plus 2t plus t plus 1, right? So this is the same as this. All we did was we separated. And all we did was we separated. So now if we take a look, it kind of helps us to factor. Right? It's easier to factor now if we take a look at this. we can factor this right here. If we take out 2t, right, if we factor out 2t, right, you get t plus 1. Okay, so if I distribute 2t times t gives me 2t squared. 2t times 1 gives me plus 2t. And I still have this plus t plus 1 equals to 0. So see, now I have t plus 1 and t plus 1 here is the same. I can now factor these out. I know it's crazy because it's so much factoring, but so now let just factor the t plus 1 out. If you factor the t plus 1 out, you have 2t left and plus 1. Right? T plus 1. This and this factors out. Right? Because if we distribute this, we get this right here. So once it's factored out, we can set these two to 0 and solve. Right? To get this, subtract 1 to both sides. And subtract 1 to both sides here. You still have 2t equals to negative 1, and then divided by 2. So 2 here cancel, you get t equals to negative 1. Now sub back. Now we're going to sub back sine x. Right, so t, instead of t, we write sine x equals to negative 1. And then we have here sine x, right, sine x equals to negative 1. And if you go to the pretty much the unit circle again, and you find sine negative 1/2, 11 pi over 6. Sine negative 1/2, 7 pi over 6. And then for the sine of negative 1, right here, 3 pi over 2. So we get 3 pi over 2, 7 pi over 6, 11 pi over 6. So this factoring is tough. I mean, some of you prefer completing the square, maybe the quadratic formula. So multiple ways of doing this one. Okay, so number 12, very similar to number 11. So same thing. Let sine x be. We can just do x this time, right? We're substituting. So we do 2x squared minus 3x minus 2 equals to 0, right? All we're doing is, instead of writing sine x, we write x. It's just easier to see. After that, we can put it back in once we're close to finish. So now you can do quadratic formula completing the square. Most of you guys, I don't know if you guys remember the quadratic formula. I don't see it given on this sheet. Right, this one way to do it. You can also complete the square, but the way that I like to do this is just factoring. It's just faster. Like, so if we rewrite this, right, we can do 2x squared minus 4x plus x minus 2. So this is the same as this, right? Wouldn't you agree? Negative 3x is the same as negative 4x plus x, right? That's just minus 4 plus a positive 1, right? The reason why we write it like this is this coefficient. Like, this helps us factor, okay? So we can take this, we can factor this. So we factor out the 2x. You get x minus 2. Right? The reason why we did this is, see, now we also have a x minus 2 here. Right? That's our goal. We're trying to have two of the same thing so we can factor it out again. So we can factor out the x minus 2, and that leaves us here 2x plus 1. And then we just set it to 0 and solve. So I know this is kind of hard because you gotta, like, why can't we do negative 3x? Like, why can't we write like a negative 2x minus x, right? Because this gives us negative 3x as well. But the problem is, if we do this, we can't really factor, right? Let's say we do that. Let's say we do that. When we factor the 2x, we get x minus 1. See, and that leaves us with x minus 2. So these two aren't the same, so we can't do another factor like here, right, to combine. So that's why. So sometimes it just comes from experience where you kind of like, okay, what works, right? So it takes that. This is a little hard. It does take a little time right here. But now back to the question. We just solve for x now. Add 2 here to both sides. You get x equals to 2. Here you subtract 1. 2x equals to negative 1 divided by 2. X equals to negative 1/2. And now we can substitute back, right? Instead of x, we write sine x. And sine x equals to negative 1/2. Sine x equals to 2, that's not even in the unit circle, right? It's only from 0 to 2 pi, 0 comma 1. So this we don't have to even worry about this. This is not an answer. But you guys know where to find the x sine x equal to negative 1/2. Negative 1/2 7 pi over 6 negative 1/2 11 pi over 6. So that's the answer. Alright, number 13 is, man, it's like number 11 and 12. We're kind of substituting again, but it's actually not too bad. If you remember the identity, so most of this, like you really have to know these charts here, right? And you gotta remember the identities, like this: sine squared theta, cosine, right? Also, you know that cosine squared theta, oh, sorry. Alright, number 13. It looks difficult, but if you remember the identities of the trig, it's pretty straightforward. Let's see. Actually, it's one of the earliest definition. Sine squared theta plus cosine squared theta equals 1, right? So we can choose, like, see this cosine square here. We can pretty much know that, well, if we solve for cosine squared theta here, if we just subtract sine squared theta to both sides, we get cosine squared theta equals to 1 minus sine squared theta. Right? This is a identity that you should probably know or learn at the beginning. So now all we have to do is we can substitute, right? 2 instead of cosine square x. Well, we know cosine square is 1 minus sine square x. So we can write 1 minus sine square x and plus sine x equals to 2. Now distribute. We get 2 times 1 is 2 minus 2 times sine square x plus sine x equals to 2. So let's get rid of these two. This 2 here. Subtract 2 to both sides. These cancel. We get negative 2 sine square x plus sine x equals 2, 0. Right? 2 minus 2 is 0. So now we just have to factor out the sine x. Right? So let's factor out sine x. Right? Because negative 2 times sine x gives you negative 2 sine square x. Sine x times 1 gives you sine x. So that's how you factor that out. So once you factor it out, you can set it equal to 0. And sine x0 is just 0, is done. Now to solve this, subtract 1 to both sides, negative 2 sine x equals to negative 1. Let's go up here. And so you have negative 2 sine x equals to negative 1. Let's get rid of this negative 2 here by dividing both sides by 2. These cancel, right? So you have sine x equals to negative divided by a negative is a positive 1/2. Right? Where is sine x 1/2? Sine 1/2 pi over 6. 5 pi over 6. So x equals pi over 6 and 5 pi over 6. Alright, number 14 looks really hard. I guess it is if you don't really know what to do. Pretty much the easiest thing here is whenever you see a power of 4, we can rewrite. Right? We can rewrite. So instead of power of 4, which is very hard to kind of, work with, we can instead put 10 square. Right? That's the same thing. Right? Like we can deal with square. The power of 4 is kind of hard. So let's rewrite that. Okay. So another easier thing to do is if we let 10 square x be just x, right? It's easier to see. That's all it is. Instead of writing all this 10 square x blah blah blah, it's just write x 4 x plus 3 equal to 0. This looks very easy, simple. You've seen this before. We can factor this out. Right? What two numbers that add to get negative 4 and multiply to get 3? Well, it'd be a negative 3 and a negative 1. Right? Negative 3 minus 1 gives you negative 4. And then negative 3 times negative 1 gives you a positive 3. There. So you get x minus 3 equal to 0. X minus 1 equals to 0. Now subtract the 10 square x. So you get 10 square x minus 3 equals to 0. And 10 square x minus 1 equals to 0. So now let's just solve. Let's just solve for 10 square x. And this is easy now. Okay, so add both sides by 3. These cancel. You get 3. Add by 1. These cancel. You get 1. So, going up here, 10 square x equals to 3. 10 square x equals to 1. To solve for 10, take the square root of both sides. See? So you get 10 x equals to plus or minus square root of 3. Here you get 10 x equals to plus or minus square root of 1. So once again, you guys remember first quadrant. Try to remember it. Square root of 3, 1 square root of 3 divided by 3. Right? If you can remember this, it just mirrors. Right? This is a mirror right here. So it just mirror over. And then the signs. The signs. Make sure you have the signs. So this, it's just a mirror. It reflects over. It reflects over. Reflect. So same thing here. If this is a mirror, it reflects. That's it. And this is a 10. Right? So you just find. Yeah, remember these are positive. These will be negative. And so we're 3. Look at your. So pretty much this you can do by yourself. Like I said, just try to remember that first quadrant. Right, 30, 45, 60. And so square root of 3, 1 square root of 3 over 3. Alright, number 15, it looks crazy, but it's actually really easy. It's just a definition, like an identity. If you look, you got sine 13 degree, cosine 73 degree minus cosine 13 times sine of 73. I mean, if you put this A, B, right, A, B, sine A, cosine B, look right here. Sum and difference formula. Sine A, cosine B, plus cosine A, sine B. Sine A, cosine B minus. So this is the minus one. So sine A, cosine B minus. So all this is equal to sine A minus B. So it's just sine of A minus B. Well, sine, what's A? 13 minus B, 73. That gives you sine of 13 minus 73, 60. 60 degree. So what's sine of 60 degree? Square root of 3 over 2. And number 16 looks really hard, but it's not. It's the same thing. This is A, B, A, B, right? This is just the identity, the formula given to you. Sum and difference right here. So cosine A, cosine B minus sine A, sine D. I know it's kind of hard to see, but cosine A, cosine B plus, what was that, minus? Yeah, minus. So cosine A, cosine B minus sine A times sine B. So is equal to cosine A plus B. So cosine A 5 pi, 5 by 12 plus pi over 4. Alright, now we just find the common denominator here is 12. So 4 times 3 times 3 cosine 5 pi over 12 plus 3 times pi is 3 pi. 3 times 4 is 12, right? We got the common denominator is 12. Now we can really just add across. And you get cosine 5 is 8 pi over 12. Now we can simplify this. Right? We can simplify. Well, 12 is the common factor of 12 and 8. We're going to divide it by 4. So 12 divided by 4 gives you 3. We're just simplifying, and then 8 divided by 4 gives you 2. And now, well, cosine of 2 pi over 3. 2 pi over 3 cosine is negative 1/2. Alright, number 17, right, it looks crazy too, but all this is just a formula. If you look, the sum and difference formula. I know it's kind of hard to see on this screen, but if you have your trig cheat sheet, it's just the sum and difference formula of 10. So 17 is like 10a minus 10b divided by 1 plus 10a 10b. So all it is just 10a minus b. So 10a, let's say, is 170 is b. So 170 minus 35. Right, 170 minus 35. What's that? You get 135. So 10 is 135. So where is 135 degrees? 135 is right here. It's 3 pi over 4. We gotta find the 10. We know cosine and sine. So you guys could do, sine divided by cosine, which is here. It's square root of 2 over 2 divided by negative square root of 2 over 2. Or you could do what I told you guys. If you can just remember the first quadrant, so we're looking for the second quadrant. So imagine this is a mirror. It just reflects. And right here is where right here is 135 degrees, and it's negative. So it's negative. And why negative? Because positive divided by negative is a negative. Alright, number 18, a little tricky. Pretty much all this is we have to rewrite. And we have to rewrite where it's in terms of something similar to what we know. So pretty much sine 5 pi over 12 can be rewritten. And if we break this down, it could be sine of, like, what's 5? Everyone knows 3 and 2, right? Right, 5 plus 2, I'm sorry, 3 plus 2 is 5. Common denominator 12. Right? So now we can simplify. If we simplify, we get pi over 3 divided by 3 is 1. 12 divided by 3 is 4. And we're just simplifying. 2, 12, and 6. So now this we know. And this we've seen before. So, same thing. This is, remember, we can say sine of A plus B. And now we gotta go back to the formula. Right here, sine A plus B. We get sine A times cosine B plus cosine A times sine B. I don't know why this got messed up. You can barely see it, so I'll write it for you. Alright, this is on your formula sheets that has been given to you. So not really that difficult, you're just copying down. So really now we substitute, right? Instead of A is pi over 4, instead of B is pi over 6. So we have sine pi over 4, cosine pi over 6, plus cosine pi over 4, sine pi over 6. Now go to your unit circle. What's sine of pi over 4? Right? Pi over 4, sine, square root of 2 over 2. And you go to unit circle, cosine of pi over 6. Okay, that's square root of 3 over 2. Plus cosine of pi over 4. Unit circle, what is it? Square root of 2 over 2. And then sine of pi over 6 is 1/2. And then we just simplify. And we just multiply. We get 2 times 3 square root of 6 over 4. 2 times 1 square root of 2 over 4. Common denominator. That's it.